In this chapter, we are going to look at what most people think of when they hear the word chemistry, and that is chemical reactions or chemical change. Chemical reactions are occurring both inside of us and around us all the time. Some of these chemical reactions are very, very simple, such as the combustion of natural gas, whereas others are very complex, such as photosynthesis or the digestion of food, which require many, many different steps and many different chemicals. Chemical reactions always involve a change in the structure of the molecules or ions involved in the chemical reaction. So let's keep a few things in mind when we are thinking about or studying our chemical reactions. The first is elements are not created nor destroyed during a reaction. They change their structure, they rearrange themselves, but they're not created nor destroyed. Atoms of different elements can combine to make new compounds. Molecules can combine to make bigger molecules, or molecules can decompose into smaller molecules or atoms. And a special type of chemical reaction is when atoms or ions gain or lose electrons, and the atoms turn into ions, where the ions can turn into atoms or molecules. Let's look at a chemical reaction that's very familiar to all of us. And in chemistry, we call this type of reaction combustion. In our everyday life, we would call it burning. Combustion reactions are reactions which involve oxygen, which is readily available in our air, and it combines with another chemical in a very rapid reaction that always releases heat or in some other form of energy, such as light, as in fire. And the products, or what the chemicals that are produced, contain one or more oxygen-containing compounds. So here's a very familiar reaction, the reaction of the burning of gasoline. Here's octane, a component of gasoline. Octane is made up of carbon atoms. It's a molecule that has carbon atoms, which are the black little spheres in there, and about twice as many hydrogen atoms. And those hydrogen atoms are the white spheres. And here's oxygen, a diatomic molecule, always indicated by the color red. When gasoline burns, and here it is burning in our auto engine, it forms carbon dioxide. So here's the carbon that was originally in our octane, and here's oxygen that was originally in the elemental form, and water. Here's where the hydrogen from the octane goes, and here's another oxygen from our elemental oxygen. So where did all the other carbons go? Where did all the other hydrogen goes? We'll get to that in a few slides. But if we have carbon atoms over here, we're going to have carbon atoms somewhere over here. And if we have hydrogen and oxygen atoms over here, we've got to have hydrogen and oxygen atoms somewhere over here, because elements are neither created nor destroyed during a chemical reaction. Combustion reactions are a type of what's known as oxidation reduction reactions. In chemistry land, they're known as redox, the reduction and oxidation. And anytime you see the term redox or oxidation reduction, what that means is electrons are actually being transferred between atoms or ions. Another important type of reaction in chemistry is what's known as a precipitation reaction. We use the word precipitation in our everyday life to indicate rain or snow falling out of the sky. Precipitation in chemistry means a solid comes out of a solution. So instead of rain falling out of the sky, we have a solid forming in generally an aqueous solution. Precipitation reactions always occur between ions. And in this class, they're always going to be in water, because the water allows the ions to move. Remember, the water molecules in liquid water are constantly moving. So this moves the ions around, and that allows them to come in contact with each other more frequently, which allows the reaction to occur more quickly. Now let's look at how we can tell if a chemical reaction is occurring. There are some clues. Sometimes they can be a little tricky, but here's some evidence of a chemical reaction. First, a chemical reaction is defined by the formation of a new substance. So that's what we're going to look for, evidence of a new substance forming. So for example, there could be a permanent color change. A precipitate could form, and that's when a solid forms when two solutions are mixed together. Gas bubbles could form. Now, we want to be careful about this because gas bubbles also form when water boils, and that is not a chemical reaction. These are just clues, and we've got to back them up with some other data to indicate that a chemical reaction is actually occurring. Another clue is that large energy changes occur. The container becomes very hot or cold, light is emitted as well as perhaps the heat. Now again, just having heat or cold changes does not necessarily indicate a chemical reaction. That could occur with just a physical reaction, but such as the dissolving of something. But this is just one clue in a myriad of others that we would put together to figure out if a chemical reaction occurred. A new odor, a whooshing sound from a tube, meaning the formation of gas very quickly, or a permanent new state, a new state that we couldn't get into another new state. So an example of this would be boiling an egg. If we boiled a raw egg, we would get it into a new form, the hard-boiled egg. We could not get it back to its original state. That is a chemical reaction. If it was a physical reaction, we'd be able to get that egg back to its original state, just like we could freeze water and get it back to its original liquid state. So here are some visuals of evidence of chemical changes. Here's the burning of magnesium. Heat is given off as well as this new substance, this white powder. A color change can occur that can't be reversed. Emission of light, here's a glow stick. This also happens when lightning bugs light up. That's a chemical change that's occurring that allows the emission of light. The formation of a gas, there are gas bubbles here, and again we want to be careful about that. And here's the formation of a precipitate. Here are two solutions, colorless, and when they're added together, they form a white solid. Now, as I said, to make sure we know a chemical change is occurring, we've got to be able to know what's happening at the molecular level and analyze the structures of the molecules at the beginning and the end to make sure there's been some rearrangement of atoms. For example, here we have the boiling of water. This would require heat absorption and gas bubbles would form. However, it's not a chemical change because we have water at the beginning and we have water at the end. The only thing that is different is the state, and we can convert these two between one another. If I condense the steam, I'd get my water back. So pause the slide and see whether each one of these are chemical or physical reaction. Photosynthesis is definitely a chemical reaction. Plants take carbon dioxide and water and chemically combine them to make a new substance, glucose and other carbohydrates. Heating sugar until it turns black. Yes, this is sugar decomposing. We cannot get this black substance and turn it back into sugar. Heating ice until it turns liquid. No, we still have water molecules and we can freeze the liquid water back to ice. We can interchange between these two states. Digestion of food. Yes, that's definitely a chemical change, and food is decomposing through the aid of stomach acid as well as enzymes. Dissolving of sugar in water. No, the molecules are still the same, and we can get our sugar back if we boil off our water, which is a physical change. Burning of alcohol in a flambé dessert. Yes, burning is always a chemical change, and once we burn it, we can't take this carbon dioxide and water and easily get our alcohol back.